Hi, we will see with you example here. First example in our statistic part of course. And what we need to do, we are given 15 of samples, tensile stress measured in megapascals for 15 samples of teens, and data were collected. What we need to do, construct the frequency distribution table. And to do this, we need to arrange the data in equal classes, determine frequency distribution, and a little bit later cumulative frequency distribution. First of all, where I would like to pay your attention, what you need to do, you have to sort the data from smallest to biggest data. So here I just copy somehow data from the task, and now let's put them from smallest to biggest. So you have to select the data and choose this sort and filter button and sort from smallest to largest. And what something happened. Let's try it again. Sort, and we have now with you all data you can see from smallest to largest data sorted out. So next one, construct the frequency distribution table. What we need to do, we have to decide how many data, how many classes we will set up. Arrange the data into equal classes. So, for example, we have here the range of our data is equal. If from largest data we take away smallest data, we will get 0.20. It's a range of data. And for example, if I would like to set up 5 classes, let's calculate the interval for each class. Range we will divide by 5 and approximately by 5, I wanted to do by 5, and approximately 0.04, it will be our range for each class. So now we can set up the classes. The first class will start with 34.40, and because range of the class 0.04, 34.44 will be right end of the interval for first class, second class, third class, and so on. Here you have to make sure that your classes don't overlap. So right hand side of interval for the class should be 0.01 smaller than left hand side for next class. Right, this is the classes. The next things what we need to do, we have to pay attention that our data here is a data for continuous data, because tensile strength is continuous data. We could measure it with 3 decimal places, with 4 decimal places. The only things, all data which we measured, and when they were collected in the table, they were rounded up to 2 decimal places. So what I'm trying to say, so for example, if your data was 34.3999, they just rounded up to 34.40. If it was 39 point, for example, 555, again it could be rounded to 34.40. But if your data would be something 38 already, 38 point something 888, we could round it up to 34.39. So we couldn't round it up to 34.40. So that is why when you work with continuous data, you are not working with classes. With classes as it is, you work when your data are discrete data. When your data continuous data, we need to set up boundaries for the classes. Lower class boundary and upper class boundary. Upper class boundary. So to calculate, to set up low class boundary, you have to think what data could be rounded up to 34.40. This could be a data which are, I set up the formula to calculate our left-hand side boundary minus 0.005. Whatever data was bigger than this were rounded up to 34.40. Look, if your classes contain 2 decimal places, the boundary for the class will be with 3 decimal places. If your classes contain 1 decimal place, the boundary will be 2 decimal places. To calculate upper boundary for the class, again, what you will do, you take a right-hand side boundary and plus 0.005. Why you are doing it? Just because all data which were smaller than this value were rounded up to 34.44. Whatever were bigger this value already were rounded up to 34.45. And now you can use this formula for all boundaries, so you can just drag the formula for all other classes. So here is classes, here is our classes, here is the boundaries for the classes. Do not confuse them. The boundaries for the classes contain always 1 decimal place bigger than 1 more decimal place more than classes. The next things which we want to do, we have to calculate the frequency. The frequency is the value how many data goes into one or another class. So we can see that in our first class contain only 2 data. Just 2 data goes here. Our second class is what? It's those 3. Let's use different colors. 3 data in this class. What is our next class? Our next class contain up to 54. Let's go to orange again. It's 5 data here. And the next class contain how many data? Up to 59. And it's what? 4 data. Sorry, here was 5. And here is 4. And just 1 data and 1 data in our last class. So this is called frequency. It's now class frequency. It's how many data goes in our classes. So if you want, you can just make it nice and set up a table for your data. Something like this. Right? Okay, let's put the table. So frequency, and next bit what we have with you, and next bit we will ask to create a cumulative frequency table. Cumulative frequency, it's set of data. It's when we accumulate the frequency, add up the total numbers. Usually what you can do here, it can be, you can, in the book maybe it looks different, but how to calculate. Start your cumulative frequency with 0. What the 0 will mean? That the data that we have 0 data smaller than our low boundary for the class. We have just 0 data for its number of data which smaller than 34.395 in our original data is 0. So the next data could be calculated. The next cumulative frequency is previous cumulative frequency plus frequency for the previous class. And now you can set up this formula manually, and because we have to repeat the same calculation, you have to make sure you always come to the total. So this is your cumulative frequency, okay? And you can see total here value. So what we done with you? We arranged data into equal classes. This is our classes. We set up the boundary for the classes. Actually, we could do it now here, but we will need it for our next bit of calculation. We set up with you frequency distribution, and we calculate the cumulative frequency. Sometimes cumulative frequency can start with those data. It doesn't matter, but when we plot the curve, it's always nice when it starts with 0. We will discuss it in a minute for next slide.